Alright, so as you can probably tell by the intro, we're going to talk about 3D printing and some of the different materials and the issues you run into with 3D printing and kind of the ups and downs and what the capabilities are, and kind of just a basic like crash course in 3D printing. So let's get started. First, we're going to talk about ABS. ABS for me has proven exceedingly difficult to print. I don't know if you can see how curved. Here, we'll use a straight wing bottom here. I don't know if you can see how curved this print is, but it peeled off the bed, and this is printed with ABS. ABS is notorious for shrinking and warping, and I've printed several kind of mounts, or attempted to print several different things with ABS, such as this guy. This is what I call a rooster tail. It's for the Armatan Rooster quadcopter, and it goes in the back. You mount your antenna, screw it down with a couple 3mm, and I fly with Crossfire, so I zip tie my Immortal T antenna to this right here, and it holds it in securely. But we'll go into that later in a different video. I have several of those printed right here. Here's one printed in PETG, and you can tell this was after messing with it for a while, trying to dial in the settings to get rid of the stringing, and I still got stringing. So, and this is a flat, like really easy to print part. I mean, very easy to print. Here it is printed in PLA, and this is in, I don't know, some Amazon PLA. It's like 15-20 bucks a roll. This was printed in the PLA that comes with the Creality CR10. And like I said, this was printed in ABS. This was printed, this is a wing rib for an RC airplane. And you can see it didn't come out perfect, but I can trim that off with a knife and it'll be no big deal. And you can still see I have glue on the back because I use glue sticks to stick everything down. But you can see there's almost no stringing with this. There's a couple little ones in here, not bad though, compared to the PETG stringing and under extrusion. It looks, oh no, it's not under extrusion right here on that flat side. It's just, I was using a translucent PETG, but you can see all the stringing and all the nasties coming up on this. So, and like I said, this was after many hours of messing with it and trying to dial in all the settings to get it to not string so bad, but I've kind of taken a break from it. So these are like the things. This is my GoPro cover. It has the mount and it fits nice and snug. It's awesome. This was ripped off a Thingiverse from, I don't know, you'll see it on there. It's the only one that looks like this, but the designer of it did a really good job. It fits nicely, and it's really strong. And this is printed in a translucent fluorescent yellow PLA. It's really strong. It printed very nicely. There's no stringing. The supports in here were difficult to get out, but we'll get into that in a minute. So it has to do with how you print it and how your layer lines match up. All my layer lines are going this way. So it was printed with a big old support in here, and it was printed vertically. These were printed vertically like this. This is a Rotorite gimbal cover, again from Thingiverse, and this was printed at 0.1mm layer heights, so it's beautifully smooth in that Amazon PLA. There's a little bit of stringing down here in the eye that you can probably see, but this was done with 10% cubic infill from on my Cura setup, and yeah, this is a 0.1mm layer height versus this at 0.2. I don't know. Oh no, this was printed at 0.1 as well. So I don't know if you can tell the difference there or not, but yeah, these are both printed at 0.1. I print pretty much everything at 0.1mm layer heights. This was printed in the Creality PLA, and I forgot to dial in my support settings, so all these supports were like next to impossible to get out, and I didn't really clean it up at all, because I'm going to use a soldering iron with like a flat pad on it to clean it up. But you can see I got some bubbling right here because it was blobbing, the nozzle was leaking. But this fits an Emax 2207 light spec. Fits pretty much any 22, 05, 07, 08, 2308, 2307, all your quadcopter motors. There's a motor pod for an airplane. So, but this printed beautifully at 0.1 millimeter layer heights. It's got a little bit of artifacting from my table getting loose and some green filament left over from the green Amazon PLA. But, I mean, it prints beautifully, so not too worried about that. So, yeah, but this is what you can run into, is your supports being super hard to get out. You can still see artifact support in there, and it's just super difficult to get out without breaking your print. So, you just time and effort to get that out and smoothed up and cleaned up. Same thing with this. This one came apart really easy. So again, kudos to whoever designed this on Thingiverse, but it fits beautifully. This ABS, real warpy, but seems overall really strong. It does snap though. You can see that this was the failed infill, and it does just kind of snap apart, which it doesn't do it to the same extent that PLA does. PLA like almost shatters on the infill or on the supports. It'll like shatter when you snap it out. But this takes me to design and printing orientation. So when you print your part, just because you have good layer adhesion, you can see that I can't even get this support out because it adhered so well. And this was a GoPro mount, and I snapped off this other ear trying to get the support out from the middle. I snapped it right off. So I was like, well, that sucks. But I can tell you why, because you're prying on the layer line. So you're prying this apart like this. You're taking this and prying it this way. And it just snapped off because the layer lines are the weakest point in a 3D print. So if this was printed this way, where the layer lines go this way, and this would have been one continuous loop with some support this way, it probably wouldn't have broke trying to get the support out. Probably, I don't know, I didn't test it. But just something to be aware of is check your orientation, find the weakest point, like a thin point like this, and make sure your layer lines are not going across the thinnest cross section of your print. So yeah, just a quick touch on, knocking over the camera. Just a quick touch on like the basics of 3D printing, kind of. You can see that time lapse in the front or in the beginning of the video. But yeah, and also just because you print your parts flat, and this is PLA, I peeled it off hot, and so now it's just a little bit warped. But if I lay it back on the bed, which I'm getting ready to do, and clean up the glue, lay it on the bed, it'll heat itself up, or the bed will heat it up, and it'll lay flat again. So you can see this one's real bad too. But PETG is much more temperature tolerant, so it's harder to do. But yeah, so there's your quick touch on the Creality CR10 with the time lapse and some really bright fluorescent PETG, some Rotorite gimbal covers to keep the gimbals protected on your transmitter. So yeah, anyway, we will keep going with more uploads and RC stuff and welding stuff. So